And it involves taking the parent function and how quickly we can then sketch a quadratic, exponential, logarithm, reciprocal, without making the cumbersome tables that we're used to making to come up with these things. Okay? So we're going to first take a look at just a general graph, which is why you don't have any kind of what we would normally see as an equation on this. We're just looking at a series of points connected. If things move it left or right, if things move it up or down, reflect it. That's going to be a key component that we look at today. Okay? So all of that's going to be taken into consideration. So, first thing, fill out the table with the current value of each point. Starting with the left.
If it's not here, I'll take it back.
Okay, yeah. So we've got 1, 2, 3, -4, -2. We have 0, 2. We have 2, 2. And 4, 0. On each of the original functions, you're going to have 3 different things that are going to happen to the original function, which is why I recommend what we do. So, on letter A, the 3 is being added outside the function. So what movement are we dealing with? Yes. We're moving up. How many? 3. So we have new y values. Let's do this one. So this is up 3 units. So you can work within the table or just take every single point from the original and just shift it up. So 1, 2, 3. 1, 2, 3. This one goes up 1, 2, 3. And this one 1, 2, 3. Then what we're going to do is we're going to connect our new lines. We're going to go here, here, here. So the shape hasn't changed. It has only moved up 3 units. So for B, where is it going to go? It's inside the function plus 2, so what does that really mean?
-2.
Yes. Which direction?
Left.
So again, just going to count from the original points. 1, 2. This is where the 3 colors come in handy, so that you can keep track of which ones are which. So we're going to take this one and go 1, 2. This one, 1, 2. And this one, 1, 2. Again, the shape should not have changed because all we're doing is shifting left on this. So we're going to draw the new. Okay. Now the last one. A negative has been applied, so that means a reflection. The question is, which values have we switched? Have we switched our x values or have we switched our y values? So the question will be, the negative is outside after the function. versus inside on the x. So if the negative was inside here as this, that would be changing our x values. So with it being outside, I'm going to go ahead and type new ones for this. New. So that means the negative is going to be applied to every one of these and switch them to now be a positive 2, a negative 2, a negative 2, and 0 doesn't change. So the new points I'm going to graph are going to be negative 4, positive 2, 0, negative 2, 2, negative 2, and 4, 0 doesn't change. So which axis did this get reflected over? Exactly. So if you change your y values, that means you're reflecting it over the x-axis. Questions? It starts getting really colorful. It's kind of fun. All right, let's take a look at the next one. Okay, so the original points, just if we need them, it's especially helpful when we have reflections. Otherwise, I don't tend to use the graph. So, our new original x and y values. So we have the same ones, right? So we're still using negative 4, negative 2, 0, 2, 2, 2, and 4, 0. This time on D, we are doing two things. So the x minus 1 means moving where? Yes, exactly. We're going to move right 1. And what about the negative 2? Down 2. Okay, so let's see what that looks like. So everything goes right 1 and down 2 as best you can. So right 1, down 2, right 1, down 2, right 1, and down 2. Those are probably the easiest movements to do because it really doesn't require you writing new values in there, just making the new graph. Okay, so on E, what are we doing? We're multiplying something by 2, so we're doubling something. The question is, what are we doubling? Our x values? Or are we doubling our y values? X, correct, because it's inside the function. If it was written like this, then we're doubling our y values. Okay? This is where it's helpful to write your new x values. So this can be helpful, our new x's. So in a lot of cases, when you double, triple something, it no longer is on the page. Okay. So we have -8, -2 that we're going to graph. If we double 0, that stays 0. Doubling our 2 becomes 4, and again an 8. So we're only going to graph the points that we can actually get to. I cannot, for 5, -8's way off my board. So I'm not going to worry about that one. So I do have 0, 2 still. I have 4, 2. And I also have 8, 0, once again, way off my page. So I've drawn this big line and just kind of stretch that, knowing it's going off my page. To indicate it's going way up to 8. And a kind of straight line. That is not. Okay. So if it's not possible on the graph page, you have just extended as far as you can, knowing it's going to not be there. What about F? A negative got applied, so we know that's a reflection. So what values are we changing? We're also reflecting our X values. So we're changing, and you can erase that. You can draw new. So we're going ahead and switch that out for our another new X's. So it becomes a +4, 0, -2, -4. When I'm multiplying my X or Y's by something, or I'm reflecting them, by applying a negative, those are the ones that I will tend to write down just to keep track of what they are. So make a new column in your table if you need to. I'm out of space, so that's why I erased mine. So I'm going to graph 4, -2, which is right here. I'm going to graph 0, 2, which doesn't change. I'm going to graph -2, 2. And I'm going to graph -4, 0. So which axis did this reflect across? Y-axis this time. Okay. Any questions on these two? The rest of this is just really getting that practice in with these two. Okay. So on your next one, you don't have a clear set of points. What kind of function are we dealing with? That's an absolute value. So here's what you're going to want is just pick, obviously you want the vertex here, and pick a couple other points so that you can get this shape correctly. So I'm going to start with, I'm going to go with 3, 3. You can take the mirror ones from each other. You can take different ones. Doesn't really matter. -3, 3, 0, 0, and 2, 2 are my three. So I've got one on each side and the vertex. So, bless you. See what you can do with A, B, and C. where the 1/2 gets applied, which value it gets applied to, shifting them, reflecting. Got a few maybe stuck on the 1/2. So what does the 1/2 get applied to, X or Y values? Y values, exactly. So this is where I might drop a column in here for A and put in some new Y values. So that's gonna be 1.5, 0 is not gonna change, and 1. So my new graph is gonna be -3, 1.5, 0, 0, and 2, 1. Again, kind of what I would expect. If I'm going to do that. Okay. B is just a moving the exact graph. The shape of your graph should not change. So X minus 3 means right 3. And plus 2. So, right 3. 1, 2, 3, up 2. 1, 2, 3, up 2. 1, 2, 3, up 2. So it's just keeping track of where the new vertex is. And the negative outside, do I change my X values or Y values by that? Yep, outside we're going to like reflect. We're going to reflect over X axis. Because that means 0, 0 doesn't go anywhere. This point is 3 units up, so its mirror is 3 units down. This point is 2 units up, so that means we're going to go 2 units down. Nothing else changed about it. Okay? See what you can do with the next 3. It's the same parent function. There's just only so many things we can fit on a graph before it just looks like a mess. Okay, so we have the same 3 points. That I'm going to use. All right, so what do we do on D? Okay, so left 1, down 1, 2, 3, 4. Left 1, 1, 2, 3, 4. Left 1, 1, 2, 3, 4. What about number 2? What changes? We're going to double the Y. So I'm going to go ahead and do that for my new Y's. So 6, 0, 4. So -3, 6, 0, 0, doesn't change, 2, 4. So a little bit skinnier graph. What about F?
That's like negative x.
We change our x values. So it is going to reflect over the y-axis. So our new x's in this case are 3, 0, -2. So 3, 3, 0, 0, and -2, 2. So did the graph change? No. On these certain functions, reflections will not change the look of the graph because of where that line of symmetry is. Okay.